Okay, good morning, everyone. Today we have two hands-on experiences working with two different workflows for two separate or two independent reasons. Please go over your Moodle week 5 and download the two CSV files and two workflow files. So please download 4 files to work with for today. So I give you a few minutes to do that. Okay, let's look at the first one, which is airline.csv. So as you see, it has city destination, country destination, everything like date, time difference, the day of the week, and distance, origin, so on and so forth. So these are, and as you see, some of the airports have multiple rows because maybe related to different flights and also different days. So based on this chart, we want to find the worst performing airlines in terms of the delay. So one of the columns is related to delay, and one of the ways is just looking to outliers. So it might be some outlier airports that have a lot of delays. So you can find them and then report them. So this is the goal for the first workflow, which if you look at Moodle, is a statistical outlier detection. So click on it and open the workflow. So when you click on that workflow, same as before, it may ask you to save it somewhere. So if you save it, then you can have it on your Knime. So next time you can easily just open your Knime and find the project in your file browser on the left side of your Knime software. So this time the workflow might be a little different, more specific, more condensed. So let's click on pre-proc Metanode. So this is a gray square. Just click on it. And when you click, there's a whole lot of word inside that node. So if you want to go back, you can, there's different ways, but I usually just close the page related to node and get back to here. So, but what is the goal of Metanodes? I just want to have a, maybe sometime you have a very crowded workflow, just very ambiguous. So you can just group some of the modules or nodes together and have such a neat workflow for yourself. But how to do that? Let's select these two outlier nodes. I click the bottom one, then press Control and select the upper one. So now I want to just have one, just condense them to one Metanode. After selecting these two nodes, just right click, and in the middle there is a create metanode and create component. Okay, so let's create metanode. Click, then okay. It asks you for a name. I'll just say metanode, maybe dash outlier. Maybe for two nodes or two modules, it's not that much productive. And again, if you want, you can just, but for previous one, maybe it's a lot more productive. We'll have so many nodes that are just related to one process. Here, I just wanted to group by arrival of the airport and also doing some filtering, some data preparation. So I made just a meta node for that. If I want to bring it back to the earlier format, just right click on the meta node that you created. Then go to hover your mouse over meta node and then select expand. So if you select expand here, it would get back to its previous shape. Then there's another way that you can summarize or just group some nodes together is just making components. So right this time after selecting, right click and then click on component, create component. You can pick any name, but if you press OK, now I have a one component. But if you click on it, you cannot go inside. It's just one solid node that does some operation for you. This is not my favorite one. I rather to have meta nodes that I can go inside and get some reports. So again, if I want to get back to the earlier format, just right click, go to component and expand. So let's start working with this workflow. The first meta node is read data, the first gray square. Just click. And it has one node. You can even make a meta node or component with just one node. Again, may not look that much productive. So you see that the default name for that node is node 734. This is just the random name which is selected by Knime. If you want to change it, just take your mouse over that node 734, click, and you can just pick a name. So first step is, yes, just take your mouse on the name. So it was this read data square. Just click, you go inside the meta node. So now let's just introduce a file into workflow. Click on CSV reader or just right click and go to configure. Now browse to the location that you have airline.csv. So just click on browse, then just go there, find the file, and then after that you can just press OK. So you can enter the CSV file into the workflow. I'll also give you a few minutes. Some of you might want to catch up or just play with some nodes. Then I go to the next step. Yes. So what's your question? Okay, so after finding your file, press OK. So some you might get a yellow bar here. Even I can right click and reset. So if it is like something like this yellow, you can just right click and then click execute. So with execution, you can bring the file into your Knime environment. Okay, then, so let's look at the second Metanode, which is pre-proc, which stands for pre-processing. Just click on the second Metanode. So as you see, I did 2 branches, and this is just for teaching purposes. Maybe you don't have to have 2 branches. So I made 2 different flow of basically data, and I had 2 different filtering, and then I treated missing data, then I group by and look at, then I joined that 2 branches of data flow. Okay, so let's look at the upper branch. Click on column filter. If you click on column filter, you see that on the right side, I have 4 columns into a green square, and I have on the left side, I have an exclude square or exclude section, which some of the columns are in the red square. So it just means for my own study, I just want to focus on 4 columns and just exclude the remaining. And you can, if you want to add more, for example, you can select date, then click on this arrow and send it back here. So it means now you are focused on 5 columns. If you're not happy with all of them, you can just click in these 2 arrows. Or again, you can just select, let's suggest another one. On the left side, click, first arrow, mean time differences. But let's say if I'm not happy with them, press your control key and select the columns that you are not happy with. And with this arrow, which is the 3rd one, you just put them back. So look here, I'm looking for city destination, arrival time, country of origin, and airport name. So that's okay. So let's see the result. So again, right click, press execute. If you right click next time and then go to the filter table, you can see it just have 4 columns because we already filter out just 4 columns. You can just browse up and down and see your data. Or same as Excel tables, you can just right click and sort them based on descending, ascending. So look at this one. I have 4 unknowns. Means for row, I don't have any data. It could happen for the other. Let me just look at this one. And this one seems I have all the data. Yeah. But again, some of the columns you may or may not have data. So you might remember previous class, I said when you have missing data, you can either drop the rows, columns, or imputation. We are not fan of dropping because we lose some data and it could bring some bias. But keep in mind, in predictive analytics, you never impute your dependent variable. So let's say you have several x1, x2, let's say x10. So these are your independent variables. You can impute them, but you never impute your y. If there is a missing on dependent variable, you should just drop that row. You cannot do anything else. So let's just work with those missing values. Click on the next node. So this is the treatment I picked. Whenever I have a string variable or categorical variable, I could do most relevant, maybe a fixed value, previous value, or remove. I just said use fixed value. Whenever is a missing, just put unknown. Or you can just put missing. So whenever in categorical variable, I have missing data, I just put unknown into the missing cell. Yes? This one? There is a missing node, missing value, just click. Oh. If it's a numerical variable, which is integer, I just say use median. If you are not happy with median, you can just click and maybe you can impute with mean, average, or maybe do nothing, fixed values. So I'm working with median. I want to impute with median. So is there anyone who wants to impute a numerical column with mean or average? So let's say this one is 20, 23. Let's say one missing. 10, 11, 5. Maybe 100. So this value is missing. Is there anyone who wants to impute with mean? What about median? This is 100. Just the age column with different data. One of the data is missing. Who said median? Why? Mean is very hard. It's very good answer. So both of you send me a note. I mean, a message. I give you bonus. Yeah. If you impute with mean, in case you have outlier, you just mess up with your mean. So maybe your imputation doesn't seem right. But median won't be messed up if you impute with median, because outliers never change your median. Median is just the middle point. Very good answer. Yeah, it's the reason I use median, but I don't blame anyone who wants to impute with mean. So right click and execute. So next one is constant value column filter. What does it do? So sometimes whole of a column is constant value, so it doesn't bring any information. It won't help you for prediction or any basically descriptive analytics or descriptive statistics, because let's say this is the airport and all of them are from United States. There is no point if I have a column which has this country is United States. It's the same for everyone. If you click on it, so I just said, look over these 4 columns and just get rid of a constant column. Press OK, right click, and execute. If you right click again, go to the filter table. Now the country is excluded because it's the same for everyone. It doesn't bring any new information. So by now, I have airport destination, amount of delay, and name of the airport. Some cities might have more than one airport, but it's the reason I have 2 separate columns. Now I want to look at their performance. I can group by city and airport name, then look at the delays of each airport in the city. So the way that you do is just through group by. So click on group by. I just said I group based on city and airport names. For example, Chicago has multiple airports. Boston, we just have 1 passenger airport. But these are my groups or group variable. But what I want to do, I want to find them like average of their delay. So for doing that, if you go to manual aggregation, you see I said arrival delay and find the mean. So it finds mean of delays for airports of cities. So if you click, right click, execute, then if you go over group table, now you can see based on different cities and airport, we have mean of arrival day delay for all of those airports. Okay, I give you a few minutes. Maybe you want to add some comments or just catch up. Then I go to the bottom flow. Okay, look at the second branch. This time, column filter adjusts city, longitude, and latitudes. This time, I want to group by all of those variables and no aggregations, because it doesn't make sense if you find the mean of longitude, latitude, it doesn't seem great. So again, it may not even necessary, but just right click, execute. Then next module is joiner. So I arbitrarily made a second branch because I want to show you how to join it. So if you never had a SQL course, you just need to identify two unique columns for two different tables, then let them to join to each other. So if you look at joiner, I just said I have city destination. These are unique, and it is just join these two tables based on that common unique column. You press OK, right click, execute. Then if you right click and go to the join table, you can see now I added like longitude and latitude to the upper branch of my data. But again, you may not even use the lower branch because the lower branch don't have that much of value. I just wanted to show you how to play with work with the joiner. But anyway, so what I did so far, I excluded some columns that I want to work with. Then I impute the data because I had some missing values, and I joined two different branch of data flow and make a unique table. In that table, I had some delays. I want to exclude the outliers and then focus on those outliers to report the issue. So sometimes your goal is just finding outliers. So you can do it with numeric outliers. I put two of them because I wanted to exclude the outliers and also the normal inputs. So if you click on the upper one, you see that in the green square, which for focusing on the variables, means the variables that I want to work with. For treatment, if you go at the bottom, I said remove outlier rows. So what does it mean? I want to get rid of outliers. Maybe after that, I can use some other modules, let's say for predictions or other works. So it just means in the upper branch, I'm focusing on the data that I want to do further investigation because there is not, they are already imputed and already I took care of outliers. So right click, execute. Then if you right click, go to treated table. You can see now I have 114 observations. Because I said I want to remove outliers. But let's say how much observation we had. So over pre-proc, right click, then select connected to join table. If you look at the numbers, here it said 121. So 121 was the original one, without outlier 114. If you look at the bottom numeric outliers and you click, then you see still I'm working on the arrival delay. And this time for treatment, I said remove non-outlier rows. So if you remove non-outliers, you just get outliers. Okay, right click, execute. Then right click and go to the treated table. Okay, these are the 7 airports that we had huge delays. For example, Spokane, I think Spokane is in Idaho. You have, on average, you have almost 3 hours of delay, which is too much. So maybe could be something wrong with that airport. Or maybe in Champaign, you have 93 minutes of delay. So if you work with a federal agency that look over the airport performance, maybe you find some issues that you need to focus more. You need to do further investigation because they are your outlier airports and might be a big issue or something very bad going on there. So you have like almost 3 hours of delay in one of them. The remaining, you have at least 1 hour of delay. So let's say you work, you want to do a predictive project. Maybe you can have a branch and then talk about your outline. Yes. Just click. This time say remove non-outlier rows. So for treatment, so I think one of you should mute the microphone. So let me see whom. Yeah, sure. I muted him. Okay, so if I remove non-outliers, the remaining are outliers. Then I can work on that report and see what's wrong with those outlier observation. So let's you talk about the outliers in your project. Maybe it could possible that you don't have any outlier. That's totally fine. Then for the remaining, you can maybe do prediction, clustering, so on and so forth. Here, I just did a basic statistics node. So it just gives me some descriptive statistics about my numerical observations. So if you right click, then execute, then go to a statistics table. You can see it has mean, max, median, standard deviation, and even a histogram of your data. Again, it could be just a part of your project workflow. Maybe after the upper outlier, numeric outlier node, you have a big branch of like prediction, clustering, and reporting. So I give you some minutes if you want to add some comments, and also if you want to just practice a little bit. Again, if you want to add comments, you can just right click and add a notation. Maybe you can say outlier. For some reason, I have one issue here, but anyway, so. So I put my notation. So next time when I open this workflow, I can see what was it about. You can add notation with several notations. Maybe if you want to put some explanation about the nodes that you are working with. So if there is no issues, please download the second CSV file. So which is cars, and just open it. So if you open that table, you see that you have several columns with no name. And the last one is just, which is again, no name, just a generic name. And there is like different cars. Sorry. So such a thing in your project, you should avoid it because you are not sure what are those columns. But just as a explanation, it has some numerical values which are normalized. So it's the reason all of the values are between 0 and 1. But for your project, just avoid such a thing because you cannot do any visualization there. So maybe you have a pie chart of column 0 and you cannot explain. So this is could be a very bad data set for your project. But again, the goal is we have some numerical values. And now we want to predict the last column, which is a categorical column. And now we want to do cross-validation. So you might remember I said in some cases, we want to be sure more about the reliability of your model. So instead of just one test set and one validation set, maybe you want to divide your data in 5 sections. Each time you pick 4 of them for training, 1 for test, train test, train test, train test. And you have 5 different combinations. So this time with cross-validation, you can have 5 different reports about your performance of your model on 5 different random data sets. So if your performance is high in all of those cross-validation, it seems you have a much more reliable model because instead of just 1 train, 1 test, you did 5 train, 5 tests. Also, for each fault, we don't want to see a lot of variation. For example, let's say for let me show you on table. Let's look at this. fold 1, 2. I'm very bad in drawing. So let's say first time I pick fold 1, 2, 3, 4 for train, and fold 5 for test. Next time, maybe I pick fold 5, 2, 3, 4, and 1 for test. Maybe next time, 5, 1, 5, 3, 4, and 2 for test. And you do it for all the folds. So let's say for the first train and test set, your accuracy is 90%. Subjective for some people, maybe 94 for some projects, or for some domains, maybe 90% is great. For some of them or not. In the next time, which you pick 4 different folds and you look at the prediction of fold 1, let's say this time 88. There is some differences, but not too much. Maybe still it seems you're reliable. But let's say in the next one, your accuracy difference is 60%. So we see 30% differences. So it's a one evidence that your model is not reliable, because you don't want to see such a variation. So when you do cross validation, you can check for this variation. Let's say if all the time my prediction is near 80 or 90%, this is a negative value. 5 different random data set. You have 5 close predictions. So maybe you can use it for future prediction. So we want to look at this and have an experiment related to this topic. So having said that, please open cross-validation underline SVM. In Python or R, the workflow is a little different. So in the Knime, you need to have 2 sections. One section, you train over all of those folds. In second section, you look at performance on each fold. So I already did one section for training, which is cross-valided with SVM. Look, in the next part, which I wanted to basically do reporting on each fold, I haven't made a Metanode. So let's just summarize it. So I pick all of these nodes, right-click. Oh, it's just deselected. So let me just use Control to pick all of them again. Right-click and select Metanode. So this time I name it cross-validation report. So now my workflow looks much better. I just made it in a very neat order. So first, I import my CSV file. Then I do training with 5-fold cross-validation. Then I look at cross-validation report. Also, look at the scorer here. This scorer gives me the overall accuracy, but the Metanode that I just created, it gives me accuracy on each fold. Okay, so first one, CSV reader. So I think it should be easy for you. Now you need to browse and select your file, open, and then press OK. With execution, you can execute and bring your data set into your Knime workflow. Okay, let's look at first Metanode. In the first Metanode, I just want to train over 5 folds. In some reports, you see people do 10-fold cross-validation. That's okay too. But here, just as an example, 5-fold cross-validation. So look, the setup might be a little new for you, but overall is close to train and test before. So in train and test, you have the partition node, which divide your data into sections of train and test. Here it does something similar with X partitioner, but look, after predictor, I also have X aggregator. But I mean, the overall goal, I want to do cross-validation using SVM. Click on the X partitioner. I just said I want to do 5-fold cross-validation. If you want, you can do 10-fold cross-validation. So then class column, it just means which column I want to use for prediction. And my random seed is 1. So you don't have to select any random seed. So each machine learning algorithm has this probabilistic nature. So what does it mean if you don't select random seed? Each time your result will be a little different. If you pick a random seed, every time you get exactly the same answer. Here I just picked 1, but again, it's not necessary. So in SVM Learner, still you need to identify which column you want to predict, which here column 18. Predictor, just use a default that I want to say, so add a prediction column 18, which has the prediction of my models. And in the aggregator, I want to see if you want to take over the predictive performance or accuracy, compare column 18 with the prediction column 18. So prediction column 18, as you might remember here, is the result of prediction. So result of prediction is prediction column 18. And in aggregator, I just telling that use the actual column 18 with the predicted column 18. So with this comparison, it can give me accuracy, sensitivity, specificity, and other predictive performance. So if you want to run this cross-validation, just right-click on X aggregator. And if you execute the last node, it just executes all of the nodes behind them. So click on execute. And as you see, several times, the SVM learner predictor just loaded and go back. It's just doing training on different folds. Okay. So now it has 2 outputs. So the upper one is for overall accuracy report. The lower one, it just gives you the outcome of, you can use the lower one for finding the accuracy of each fold. As you see here, we don't want to see a lot of fluctuations because a lot of fluctuation means your model is not reliable. If you right click and go over prediction table, you can see the predicted outcome is in the last column. Also, I have a fold column. It just means how my data is divided. So first is a start from fold 0, fold 1, 2, 3, 4. So is a start from 0 to 4. So I have 5 folds. Okay, I give you a few minutes if you want to add a note or just want to practice by yourself, then I go to the next part. Okay, so in the after cross-validation training, I have two branches. The upper one, I want to look at overall accuracy. In the lower one, I want to look at the accuracy of each fold. So in the scorer, just click. You just need to identify what first column is actual data or actual dependent variable. Second column just means the prediction column. You OK, right click and execute. So after execution, just right click, go to accuracy statistics. So for each category, so I had 4 categories of cars: van, sub, bus, and Opel. So you can find their accuracy and precision, sensitivity, specificity. So an overall accuracy is 74. For each of them, you also could look at true positive rate, false positive, true negative. You can find all of those statistics. Let's say in Titanic dataset, instead of using a machine learning algorithm, you just toss a coin to predict if someone can survive or die. Do you think what could be your random prediction performance or random prediction accuracy? 50%. So in Titanic example, if you do a lot of effort to use machine learning for prediction, and your accuracy is close to 50%, it seems you waste your time. But even if you toss a coin, you can get 50%. Same as here. So we have 4 categories this time. So if I just randomly assign a category for prediction or just predict randomly, I expect my accuracy should be 25% or 25% precision. Here, they are far from 25. So at least my model is not too bad. Because let's say in one category, if it's close to 25, I won't be that much happy. So the base comparison is just you compare your model with a random prediction or random assignment. If it's more than that, this is one at least a minimum, okay. Then maybe here you look over each category accuracy and also our overall accuracy. So some domains might be 74 is good. For some research or some domains, maybe 90% is good. So the later one is very subjective. So maybe you can look at literature and see what other people did. If many people did near 60% and now you improve it to 74, means you did a really good job. So in comparison with the previous studies or literature, you did some improvement. But anyway, as I already said in your project, you need to consider 3 different approaches for improving your predictive performance. Maybe you may or may not be able to improve your performance, but at least you should try 3 times. Maybe you do 3 different algorithms or 3 different data preparation, maybe different imputation. Maybe instead of SCM, you use neural network or logistic regression. So I need at least to see 3 branches that you try to improve your performance. If you can, that's good. If you cannot, that's fine too. Okay, so by now we look at the overall accuracy and also for each accuracy for each category. With the lower branch here, which is cross-validation report, we look at predictive performance of each fold. Just click on it. So similar to the training part, here also you need to have a loop. Each time it takes one fold of your data. In that fold, it calculates the accuracy, sensitivity, specificity. So you need to have a group loop start and end loop. Here I'm just saying that the group is fold number because I want to do cross-validation over different folds. For a scorer, I want to say each time you compare column 18, which is the actual data, with prediction column 18, which is the result of predictions. Then this is not very intuitive, but you need to have a table to row to variable and variable to table row. In these two, you just identify the performance measure that you want to consider. For example, here I just said I want accuracy, sensitivity, and specificity. And here I just identify those 3. Then in group by, if you look at manual aggregation, I'm saying that for accuracy, I want mean and standard deviation, same for sensitivity and same for specificity. So for accuracy, sensitivity, and specificity, I want to look at the actual value and also the variation. For example, here the variation is 90% minus 60%. So there's like 30% variation. Instead of having arbitrary measure, I want to look at standard deviation of variation. So standard deviation of accuracy, sensitivity, and specificity. So yeah, I think first time I need to load. If you run it, shouldn't give you any error. So if you execute, yeah, that works. So again, in each fold, I'm comparing prediction and actual values, and also I'm looking at these 3 different performance measures. And at the end, I want to look at the mean and standard deviation to see the deviation or variability of each performance measure. So if you right click and get to the group table, so accuracy 74%, which is was before, and a standard deviation of accuracy, which is the second column, is just 0.016. It seems good to me, but again, depends on the domain. Sensitivity and especially both of them are high, means there is not that much of bias in your model. Because sensitivity and specificity look at the your performance of different subgroup, could be either female, male, or here you have different car brands, or maybe it could be different ethnicity. So it's the reason we look at sensitivity and specificity together. If you look at the specification of columns, you can also look at the lower and bottom. Let's go over loop end and then collected result. So this is the results for each fold, started from value 0 to 4. And you can see sensitivity, specificity, and accuracy on each fold. As you see, it's not too bad. Sometimes the sensitivity is really high, 100%, which is weird. But let's compare value 0, which means actually I want to compare sensitivity and specificity of fold 0. Look, for one category, maybe you can prediction is almost 100% versus for the other one is maybe 6% differences. This here might be a little strange for you because sensitivity and specificity is for 2 class classification, but here I have 4 classes. You can expand that content to 4 class classification. It's a little out of context for this class, but maybe let's say for van, maybe you can have van as one group and the remaining as the other groups. So you can now change your 4 groups to 2 groups, van or non-van. Then sensitivity specificity, I think, is more straightforward. Here's a summary of all of those calculations. But usually, if you want to do put the write-ups, intuitively, you should talk about 2 groups because it's how the sensitivity and specificity works. Again, here, since I have multiple classes, it sounds a little weird, but basically, sensitivity and specificity means just one group versus other groups. But here, you're not sure whom is for whom. But when you have 2 class classification, you can easily say, for example, sensitivity could be performance for, let's say, white people, maybe specifically look at the performance for people of color, or men versus women. Here it could be a little strange, but the point is, when I summarize my result in the group by, for accuracy, sensitivity, specifically, there's not that much of huge variation since the model is very reliable. On each fold, you have close predictive performance. Usually, when you have more than one class, or sorry, more than 2 classes, it's better to just look at accuracy because talking about sensitivity specificity could be a little ambiguous. Here, I just wanted to show you that you can add other measures, but again, I think it's better just focus on the accuracy. Questions? I also don't see any question from people over Zoom. So from now, also we have other sessions. For example, we do text mining. So you see that for text mining, you might have different data preparation because you need to convert your textual data to numerical equivalent. Because machine learning algorithms just work with the numerical data. You cannot just put everything in. So we will have some other workflows. Hopefully, for your final project, you can, if you need extra data, maybe you can look over each workflow, and maybe you pick 3 or 4 workflows and just merge them together for your own project. For example, maybe if you want to do cross-validation for your project, you can use this workflow and use the previous one. So you can basically put both of them in one workflow and use a part of it for maybe data preparation, getting rid of outliers, imputation. Then the output of that workflow could just come here and you do cross-validation and report your results. So most likely for a better project, maybe let's say, then we can Control C. Now look, so maybe instead of reading from here, I connect the output of here to here. But I think you got the point. So maybe you can just merge different workflows. Even you can Google it. Let's say for your own project, I didn't cover enough modules that you need. You can just Google and for based on your certain need, you can just drag and drop. So let me just do a random Google. So for example, let's say let's say outlier node in Knime. So the cool thing about Knime, you can just go over a Knime website, select, drag and drop here. Sometimes when you drag and drop, it asks you to install some update or some packages. If it asks you, you just click next, and let those your node to get updated. Even this is just one node. You can even drag and drop entire workflow. So let me just Google text mining Knime workflow. Oh no, this is just a PDF file. Look, somebody even did a complete project. So you can drag this icon and just put it here. Look, I brought entire workflow here. And now it asks me to update my Knime because I need to have extra packages to be able to run that workflow. Otherwise, you see there is some red crosses. It just means I don't have enough package or I need to update my Knime. Then my Knime can recognize these red crosses. Right now, I cannot recognize. Anyway, that's for today. Let's just have our attendance.